Thanks. Okay. So I would like to start with a very, what you can say, traditional question that we all engineers have. Am I audible, guys? Yeah. So that was my question. Okay. So starting off, hey content stack, this is Advait, and today I need just your 20 or 25 minutes to discuss about this topic. Think big and scale smart. So basically what we are trying to achieve here is to innovate, to scale, and thereby to succeed. Okay. So let's start. So the very first question that everybody would have at this point is what exactly is scale engineering? So I would like to address that with an example. Okay. So suppose you have planned a birthday party for your friend. Okay. So, but I have this confined space. I have a DJ, I have a cake, and I have invited a lot of guests, right? But I don't know how many of them would show up, right? So once they start coming in, the confined space becomes too small for me. So that brings in chaos, right? Somebody is poking the cake, somebody's on the DJ, and there is a lot of tension over there. So that is not efficient. But what if in another scenario, I give you a football sized field to organize that party, but only 10-15 people show up? Is that efficient? No, definitely not. Why? Because we are wasting a lot of resources over there. So this problem is basically addressed by the solution that we know as scale engineering. So what if to our existing problem, if I give you a solution that if I give you a room that could be auto scaled as and when the guests are joining, if I have 10 guests, I would have a space that would be able to incorporate those 10 guests and so on and so forth. So I would have a much better way for them to experience that party and for me as well to get a good night's sleep. So that is exactly what scale engineering is. Okay. So now let's look at a proper definition for that. So scalability is being able to do more with a lot less. Okay. Now the very next question and the most fundamental question: why in content stack, or why as an organization we need to scale, or basically try to achieve scale engineering? So I would like to revisit what Nishant said earlier last year, is that we want to manage the world's content. So if we are planning to manage the world's content, how are we trying to handle a billion users data? How are we making sure that our software takes care of a billion users at a time? That is a scary question, right? So that exactly gives us enough reason to pursue scale engineering. Because if we don't have scale engineering, it would be a wastage of resources, wastage of efforts, and so on and so forth if we try to cater to those users. So that would be the answer to that. Also, there are other benefits, right? Beginning from, it will make your business bigger, better, and stronger than the Hulk, definitely. But in real terms, it will get you more customer satisfaction, basically. Why? Because our customers would be more happy to use a more reliable version of our software, right? Which never goes down, is auto scalable, is very easy to use, and is very fast. Okay. The next thing that we would get is enhanced data analytics. Why? Because if we have more users, if we have good amount of users coming in on our platform, we could use that data, generate models, and then give them another user experience, or we will be able to identify those places that we need to work upon, or which we are doing good. So that would be another advantage. This would eventually lead us to grow and get a cutting edge advantage over our competitors. So that would be like the benefits for the organization. Now, the third question. So the third question is, okay, now I understand what is scale engineering, why do we need it? But what does it exactly look like? Okay, so I hope everybody knows this man, right? He's Virat Kohli. And also this glimpse from the match, which was an epic match, by the way, that was played between India and Pakistan in the T20 World Cup, right? So it was a very pressure situation wherein Virat Kohli stepped up and made sure that the Indian team was victorious. So it was a lot of pressure, right? But that's not the point we are trying to make over here. So if you notice at the top right corner, Hotstar on that particular day managed to cater to almost 16 million users concurrently accessing their content. So this is a great engineering excellence, right? So how did they do that? Were they expecting this number? Definitely not. Why? Because the last record that they had of number of users joining in was close to 12 million or 13 million. So that day was exceptional, just like the match. So they had to cater to almost 60 to 70, 6 to 7 million more users. So how did they manage to do that? Definitely there were no engineers sitting around and scaling manually, right? So that was pretty much a good example of scale engineering. So let's now decode what exactly Hotstar, Disney Plus Hotstar is doing right now. So if we look at the statistics, they have around 400 million downloads, right? Out of which they have 100 million active users on a daily basis and 300 million on a monthly basis, which are looking over a 100K hours of content. So it is a good amount of content that they are giving to their user base, and they are available in 5 countries. So let's assume they have 5 data centers as well. Now, this scale helped us to cater to our passion of our cricket, right? So every time you watch a cricket match, every moment is as important as the whole match. So to ensure that, Disney Plus Hotstar pursued scale engineering. Okay. So now the question that comes in mind, so what did they do exactly to make sure of that? So I have listed the top 5 engineering practices that made them achieve the unthinkable. Okay. So starting off with auto scaling. So we were like discussing it, auto scaling, the shape shifting octopus, as I say. So it is nothing but that it can shift its shape from smaller to bigger as and when required. So that is what auto scaling does. You will have horizontally and vertically scaled servers as and when users are trying to join. Secondly, what they did is they cached and did content prefetching. So basically, when you're watching a frame, the next frame was automatically brought onto the cache. So that made it much faster and effortless experience was provided, right? So we can call that as the teleporter. So right before you see it, it was already present. Third thing would be the adaptive bitrate streaming, or we can say the chameleon. Why? Because it was shifting itself from low to high. So suppose if you were traveling on a train and watching the India-Pakistan match and you have a low internet connectivity. So does Hotstar don't give you content? It will. What it will do, it will reduce the quality so that you don't miss the important parts of the match, even if the quality is not up to the mark. So it takes care of that. And the fourth one being content checking and parallel streaming. So this is a pure example of concurrency, which enables a faster experience, which we call the flash. And finally, the disaster recovery and redundancy, or the Phoenix, wherein if the system fails, it gets back as quickly as it failed. So those are the 5 engineering practices that made sure of what we saw earlier. So they could cater to a lot more users than they thought of. Okay. Now, the fourth question that arises is these all are organizational benefits, right? So what exactly is it for me? Why should I, as a developer or generally as an engineer, should pursue scale engineering? What would I benefit from it? So there are the top 3 reasons that I, as a developer, would pursue scale engineering is I will future proof my skill set. So as we know, we are growing digitally on a very large basis, on a global level, right? So we have new users coming in using our software, our apps, and the count keep on getting exponential. So if I'm building something that can take care of that, it is a good skill set, right? Secondly, you learn to be creative and innovative. You start thinking out of the box. You start thinking the worst case scenario, and after that as well. So that makes you a good engineer, a good developer. And finally, you build resilient systems so that other people can include it, like we did include Hotstar on our PPT, so that they could use us as an example of our systems. So that are I'm pretty much convinced that you guys would agree to that. So these are that would be the relevancy to an engineer. Okay. Okay, so now we know that as an engineer, I need to pursue scale engineering. So starting for that, we won't directly jump to the coding practices or the methods to do that. We would firstly follow the mindset that you need. So that can be pretty much defined with this. So as engineers, we just don't want to build great products. What we want to do is we want to serve millions of users without breaking a sweat. That should be our mindset when we are building something, right? Okay, then moving on, we need a solid foundation for our structure. Every structure needs a solid foundation, right? So even scale engineering needs a solid foundation. So what are the 8 steps that we need to do to make sure of it? So firstly, we'll need to identify the bottlenecks and optimize the critical sections of our code. So first step would be to take care of those sections of our code which could fail eventually and lesser the probability over there. The third thing would be to evaluate the efficiency of databases and implement caching mechanisms. So caching is a good friend of ours. It could get us the data so that we don't have to go to the server again and again and ask for the data. And similarly, databases will need to have a good amount of queries, but those should be efficient, definitely. If we are getting the same data doing 5 queries, we should make sure that we should use the least number possible. And even database scaling, which we will discuss ahead. Okay. And the other 4 would be explore parallelization techniques, like take concurrency into the game, bring concurrency into the game, handle the error properly, and make sure we are fault tolerant. And finally, scaling the infrastructure horizontally or vertically as per the user's need, as per what the organization's requirements are. Do that. And finally, we should continuously monitor and analyze our performance metrics to make sure where did we do good and where did we not, so that we could use that as a roadmap for the next things. Now, one thing that caught my eye over here was the efficiency of databases, basically scaling the databases. So how could we do that? So we'll discuss that after I do one sip of water. Sorry. Okay. Okay. So there are pretty much roughly two methods that we usually use. So the first one being range-based partitioning, or you can say range-based sharding. So what do we do here is where data learns to stay within its price range, just like a shopaholic trying to stick to a budget. So basically we know our range and we have to stick our data inside of that. Pretty simple. Second one would be hash-based partitioning or sharding. So where data, it is like a magical sorting of our data. We put it using a hash function, and whatever the result is, we'll put our data over there, whatever it points to, right? But the question here is, does this make sure of everything that we are trying to achieve? The answer is no. Why? There are 3 problems with these 2 approaches combined. So the first one being data imbalance. So data imbalance is nothing but due to those 2 partitioning methods, you could have more data on one server and lesser data on the other. That is not efficient. Secondly, scaling that is not good, because if you try to add or remove servers over there, that would lead to errors, because reassigning of the data is a big task. And finally, availability, risk, and failover. So if your n number of servers fail simultaneously, it will be a chaos in the existing 2 methods. So the solution would be to use hash-based partitioning, but in a different format. So what we'll do here is we'll use it, which is known as the hash consistency. So what we do here is we assume a circular ring wherein every data is placed at a random angle of that particular circle. So if you can see, there are 5 keys that I want to store at different angles. So those are randomly assigned. Similarly, we can do that for servers. So I have A, B, and C servers randomly assigned an angle and one foreign key to the keys that we have. So to label where the exact data is present on which server. And it is usually done in the counterclockwise direction. The assignment is usually done to that. So what this makes sure is, if you keep on adding new servers and if you keep on adding new data, it will be much more easier to assign that a random angle rather than doing it in a chunks of data and reassigning. And even if a server fails, or if we are trying to add new servers, it will be much more faster approach to reassign data rather than doing it in range-based partitioning or simple hash-based partitioning. So that is one thing that I wanted to discuss in detail, because database scaling is that problem which every organization faces. So this could be the solution for that. The another way of looking at is, it depends on what the organization is trying to achieve. But yeah, those could be the main points for that. Okay, now we did look at how to build a solid foundation. Now what to do next? So we should automate like there is no tomorrow. Okay, so what are the steps to do that? So I would like to distribute that in 5 steps so that you can sit back and enjoy your cup of coffee while the automation takes care of your work. So firstly, definitely we would identify the manual processes. Example that we can take here is resource provisioning. So if resource provisioning is manual, scalability doesn't happen, because that is totally a person's job to do that. So if he is on a coffee break, your servers are gone. Okay. So next thing would be to select automation tools. So automation tools. Okay. So see, like example would be CI/CD, infrastructure as a code. So better example would be Terraform. In our case, we use Terraform as our information as a code tool. So that would be it. Third would be to develop those workflows that we want to automate. And finally, we would test it and monitor it for any errors or so. So that would be like the 5 steps to automate the process, what we have did after building a solid foundation. Okay, the next thing, which is like the hateful thing that every developer finds. So it is testing. Test, and test some more. So me also as a developer, I hate to test. I hate to write test cases. Everybody, I would assume, agrees to that, right? So, but that is very essential when you are trying to scale your code. Why? Because that gives you gives your code a good workout. Okay, so there are 5 topmost testing techniques that we could use to get to that scalable level. First one being unit testing. So every piece of code that you write should be unit tested so that you don't get any hidden surprises later on. Second would be load testing. It would be like throwing a party and then expecting a lot of more guests than it could accommodate to come and test it, so that you could make sure of it that they are satisfied. Third would be stress testing, just to see if it can keep its cool. Your software doesn't panic or it doesn't slow out. So stress testing could make sure of that. The fourth one would be usability testing. This is the most important testing, because as a developer, we have a different perspective to build systems. But as a user, it is the original perspective that we are trying to achieve. So if a user is scratching his head using your system, then you're doing something wrong. So you should be able to write some test cases, or you should be able to derive some processes that make sure that usability testing is a must for all your softwares. And finally, recovery testing, because even if we achieve everything, even if we are perfect, there are high chances that systems could fail. That is basic human tendency. So recovery testing would make sure how fast can we get back to the normal working process if we hit any failures. So those would be my 5 steps to test scalability. Okay. Now, just to summarize it, so everything that we learned, so that would be like a roadmap for scalability. We'll need to adapt it in our day-to-day activities, like as a developer or as a DevOps engineer or as a QA engineer. We would have to adapt those steps that we mentioned and make sure that we are writing such good code, such good scalable code, that we are building very good systems, right? And we should just keep on repeating that, so that we don't ever, so that people can use us as an example in their presentations, right? So thank you so much for being such a good audience, and keep rocking. Thanks.
Well, thanks, Advait, for sharing us with all the insights.
Yeah.
Do we have questions for Advait?
Very good, Advait.
Thanks.
So
Thank you.
how are we scaling? You're honest.
Uh,
You're the super admin, super admin, right? So basically, what is your opinion? How are we doing on the scalability?
Okay, so that's a very good question, actually. But I'm thinking of a way out of that question, and to answer it in a more diplomatic way, to be honest. Okay. Hmm. Correct. Yeah, we are scaling good. I can hear you, but people at the back cannot.
So, okay, let me repeat the question in another way,
Yeah.
actually. What would be the maybe one or two things that we should do to be better scalable in our architecture or what we are doing right now?
Okay, so like if you ask me, the first one would be database scaling. So that is the root cause of all problems, right? So if you don't if you don't have a scaled database, so that could cause a lot of problems. But scaling databases to the best is the way to go in the beginning, and then we could take in some more testing techniques that are missing in our suits. So as a developer, and even as this is a message to other developers as well. So we should be writing more test cases. We should be making our code more reliable. So that is, and we are on the right path. So that is why I took this example. So yeah, we are on the right path. Just to answer your question.
And just to add to that, I mean, because it's database, it doesn't matter if you know only MongoDB. There are a lot of other databases.
Correct.
Please be open. So the examples which he was giving was a good example of Cassandra. So
Correct.
whatever he was explaining is exactly what Cassandra does. So if I go and recommend Cassandra to super admin, he will tell me it will take 1 year for me to go to Cassandra.
No.
So
no
first of
activity.
all, I would like to tell there are a lot of databases apart from MongoDB. Let's be open to that first. I understand we are heavily based on Merl stack and all that, but as per our requirements, wherever we can fit whatever database, we should at least be open to try it.
Correct.
And how are we scaling, Vasu? I mean, to add to that, because I know the problem very deeply and closely. Today we are serving 1 billion calls, but are we ready to serve 100 billion calls? Are we even thinking in that direction? And to do that, am I even like building my code to do so?
Correct.
So that is what is the major takeaway, I would say.
Yeah.
No.
Saqib dil pe le liya. But yeah, but I can tell you, I know we are doing 1 billion calls plus every day, and the DB team is doing an exceptional job in managing the whole stuff.
Round of applause for Saqib and team.
Advait, that was a good session. I think it's a good reminder of the scale engineering.
Correct.
And I feel you can't be ready for the scale from day one. And it's also a continuous journey.
Correct.
So when we started, it was like we did not expect billion calls. Forget about billion, not even like billion calls. So at that time, it was all different. Now, Saqib is saying, are we ready for, let's say, thousands of billions of calls? I mean, we can scale that, but it's not cost efficient.
Correct.
Okay, but now consistently we have to work towards making sure that we are scaling with low cost. I mean, anyone can scale, like you just keep adding servers and servers, but that's not efficient. So scaling with low cost is, I guess, the the key here.
Correct.
And Sakib, yeah, we need to be prepared for 100 billion calls.
Okay.
Billion के नीचे बात ही नहीं होता आपने.
Thanks, Advait, and
Yeah, thank you, guys.
thanks, audience, for actually